Hello children, welcome back to the digital classes. I hope you are all doing well. You might be all excited to learn some new concepts in today's session. So let us start our session now. So before we go into our session children, let us quickly recap what we have learned in our previous session. Now here you need to find out the formula for LSA TSA of cuboid as well as cylinder. Now the first one is LSA of cuboid. What is the formula children? That's right. It is 2h into L plus B. Now what about TSA of cuboid children? You are right once again. It is 2 into LB plus BH plus HL. Now what about the volume of the cuboid children? You are right once again. It is L into B into H. Now let us go for cylinder children. Now what is curved surface area of a cylinder children? Yes, it is 2 pi RH and TSA of a cylinder is 2 pi R into R plus H. And the last one, that is volume of a cylinder, is given by pi R square H. So these are all what you have already learnt in our first session. Okay children. Children, can you tell me what are 3D objects? Yes, the figures which have length, breadth and height are called as 3-dimensional figures or 3D objects, or even they are called as solid figures. Now what is a right circular cylinder children? You are right once again. If the line segment joining the centers of the base and top is perpendicular to the base, then we call it as a right circular cylinder. Children, can you just identify the figures shown on your screen? Yes, you are right. A globe and a birthday cap. But what is the shape of these figures children? The first one is a sphere and the second one is a cone. So today children, in our session we are going to learn about surface areas and volumes part 2. So in this we are going to learn about the volumes of sphere as well as the cone. By the end of this session you will learn surface area of a cone, volume of a cone, surface area of sphere and also volume of a sphere. Let us see the objects shown on your screen children. Yes, the first one is an ice cream, the second one a carrot, third one a birthday cap, whereas the fourth one you might have seen these when you are passing on roads, right children? Mostly the traffic police, they use this. Now what is the shape of all these objects children? That's right, these objects are in the shape of a cone. Now children, we will learn more about cone. Take a look at this cone children. Yes, here is the circular part, we call it as a base. Then we have a curved surface and later on there is a point which we call it as the vertex of the cone. So let us consider the cone again. This is the radius, the line joining the center and any point on the circumference of the base, and also we have seen a perpendicular drawn from the vertex to the center of the cone. Now such a figure we call it as a right circular cone. So children, did you understand what is meant by a right circular cone? Yes. If the line segment joining the vertex of the cone and the center of the circular base is perpendicular to the radius of the base, then we call it as a right circular cone. Okay children. Now let us see the radius part. Yes, R is the radius. It is the line segment joining the center of the base of the cone to the any point on the circumference of the base. The line segment joining vertex and the center of the cone. Now this line segment we call it as the height. So what is the height children? It is nothing but the perpendicular distance between the center of the base and the vertex. Now apart from this height, we have one more height also. Let us see this children. Yes, can you see that children? Yeah, this height is denoted by L and we call it as slant height. So children, you need to be very particular in this case because we have two heights. One is the slant height, the other one is the normal height. Normal height is nothing but the perpendicular distance, whereas the slant height is inclined at certain angle. Okay children. Now let us consider the slant height L, the vertical height H and the radius R. Now does this have any relationship between them? Let us see. If you notice, AOB forms a right angled triangle with O as right angle. Okay, children. Now, children, as soon as we heard about right angle triangle, do you remember any theorem? That's right, it's Pythagoras theorem. Can you tell me what is Pythagoras theorem? Yes, it states that in a right angled triangle, the square of the hypotenuse is equal to the sum of the squares of other two sides. So, take a look at the right angle triangle, children, that is triangle AOB. In triangle AOB, what is hypotenuse, children, here? Yes, the side which is opposite to 90 degrees, this is 90 degrees, and side which is opposite to 90 is AB. So, this is the hypotenuse. So, hypotenuse square, that is AB square, is equal to, what are the other two sides, children? Yes, we have OA and OB as other two sides. So, that is equal to OA square plus OB square. Now, let us substitute these values, children. AB is L, OA is H and OB is R, and substituting we get L square is equal to H square plus R square. Now, let us consider the value of L, children, here. So, what is L now? Yes, L is equal to root of H square plus R square. Now, this value of L, that is root of H square plus R square, this is the relationship between L, H and R. So, children, so you might have seen these birthday caps, right? They represent a cone. Okay, children. Now, let us cut open this cone and see what we get. Okay, children. So, I am going to take a scissor and cut this cone. So, on cutting this cone, children, if you cut open a cone, see, you are going to get a figure of this type. Now, what is this figure called as, children? Yes, it is a sector. Now, in this sector, if you notice, these two represent radii of the sector, and this curved path represents what, children? Yes, the length of the arc, children. Okay, children. That means, whenever we cut open a cone, we are going to get a sector. Okay, children. Now, let us say the same thing using our images on the screen. So, here we have taken a cone, right, with slanted L and radius R, and when we cut open this, we got a sector. Now, children, I am going to divide this sector into different, say, parts, say some equal parts I am going to divide. So, each are going to represent as a triangle. If you cut into very smaller part, it represents a triangle. Okay, children. Let the base of each triangle be B1, B2, B3 and so on. Then the height of the triangle is nothing but the slant height of the cone, children. If you can notice from the figure, the height of the triangle is nothing but the slant height of the cone, which we denote it by L. Now, area of the cone is nothing but the sum of all the areas of triangle. That means, if I add all the triangles into which I am dividing, the area what you get is nothing but the curved surface area of the cone. So, we know that area of triangle is half into base into height. So, for the first one, what is the base, children, here, if you can notice? Yes, it is B1. So, half into B1 into what is the height, children? L, that is slanted. So, L. For second triangle, again it will be half into, now the base is B2 into L, plus the third one half into base is B3 into L, plus so on. Okay? We can take any number of triangles. Okay, children. Now, do you find anything common in this, children? Yes, we find half, and anything else? You are right, L also. Now, take out these two common, children, that is half L. So, if you take half L, what is left, children, here? If you notice, yes, we are left with B1 plus B2 plus B3. Now, if you go on adding all these B1 plus B2 plus B3, what do you get, children? Yes, we get the circumference of the base of the cone, half L into circumference of base of cone. Now, children, what is circumference of circle formula? Yes, it is 2 pi r. So, we get half L into 2 pi r, and here both 2 and 2 in numerator and denominator will get cancelled, and what do you get, children? Yes, pi into r into L. This is the formula to find the curved surface area of a cone, which is given by pi r L square units, where L is the slant height and r is the radius of the cone. Let us find out the total surface area of a cone. So, if you are going to cut open this, we have seen we are going to get a sector and a circle also, if it is not a hollow cone, right. Now, the base is obviously in the form of a circle and the other part is almost looks like a triangle, okay children. Okay. What is the total surface area of the cone, children? Yes, it is the curved surface area of the cone plus the area of its base. Here base is nothing but circle. Now, let us substitute these values. Just now we have seen the CSA of a cone is pi r L plus, now what is the area of circle formula? Pi into r square, or simply we say pi r square, right children. Now, let us substitute that also. Again, do you find anything common here? Yes, we find pi and r both common. So, if I take pi r common, we get L plus r. Therefore, I can say TSA of a cone is given by pi r into L plus r square units. Now, children, let us find the volume of a cone. From the activities, that is, if you take a cone and a cylinder with same height and say same radius, you will notice that volume of a cone is 1/3 volume of a cylinder. But what is the volume of cylinder formula, children? Yes, it is pi r square h cubic units. Now, let us substitute this. You get 1/3 into pi r square h cubic units, or I can write simply 1/3 pi r square h cubic units. This is the formula to find the volume of a cone. H is the height and r is the radius of the cone. So, children, we have learnt the curved surface area of a cone as well as the total surface area and also the volume of a cone. Now, let us learn the surface area and volume of another solid, that is sphere. Now, let us see. Now, take a look at the images shown on your screen. Yes, a globe, a football and a tennis ball. Now, what is the shape of these objects, children? Yes, these are all in the shape of a sphere. You are right. Now, we are going to learn about a sphere. The line joining the center to any point on its surface, we call it as its radius and denote it by r. The surface area of a sphere is given by 4 pi r square. Now, take a look at this object shown on your screen, children. What it represents? Yes, it represents exactly half of a sphere. We call this as hemisphere. Half the sphere is called hemisphere. Again, the center and the line segment joining the center and any point on the circumference is the radius r. Okay, children. So, curved surface area of hemisphere is given by, since it is half of a sphere, so we get half into surface area of a sphere. Now, let us substitute the values. Half into 4 pi r square. How much you get, children? Yes, we get 2 pi r square. This is the formula to find curved surface area of a hemisphere. Now, let us find the TSA of hemisphere. So, TSA of hemisphere is its curved surface area plus on the top there is a base, right, which is in the form of a circle. Now, let us substitute the values. CSA of hemisphere is 2 pi r square plus base is a circle and its area is pi r square. Now, adding these two terms, we get 3 pi r square. So, this is a formula to find TSA of hemisphere. Now, let us find out the volume of a sphere with radius r. Okay, children. Now, for that, what we are going to do is, we are going to divide the sphere as shown on your screen. Now, from the center of the sphere, I will consider only one particular area. Now, how it looks like, children? Yes, it looks like a pyramid. Okay, children, that means we have divided the sphere into a large number of such pyramids, and you know this particular part is called the base of a pyramid. Now, let us derive the formula to find the volume of a sphere. Let the area of base of the pyramids be A1, A2, A3, so on, and height of the pyramid is nothing but here radius of the sphere, and volume of pyramid is given by 1/3 the area of base into height. This we have already learnt in our previous session. Here the base area is nothing but A1. So, A1 into height is r. So, I got 1/3 into A1 r. This is for one pyramid, but we have many such pyramids. So, the volume of a sphere is sum of all the volumes of these pyramids. Now, let us add all these volumes of pyramid. So, you get 1 by 3 A1R plus 1 by 3 A2R plus 1 by 3 A3R and so on. We notice 1 by 3 is common and also R is also common. So, let us take out these two as common factors. So, if you have taken out 1 by 3 R as a common factor, you are left with A1 plus A2 plus A3 plus so on. Now, in adding all these things, you get simply the surface area of sphere. But surface area of sphere is how much, children? Yes, 4 pi r square. So, on multiplying this, you get 4 by 3 pi r cube. Hence, we can say that the volume of sphere is 4 by 3 pi r cube cubic units. Now, can you guess what is the volume of this hemisphere, children? Yes, you are right. Since hemisphere is exactly half of the sphere, so half of 4 by 3 pi r cube, which is 2 by 3 pi r cube cubic units. So, children, we have seen the formula to find curved surface area, volume and TSA of cone, and also we have seen the formula to find volume and surface area of both hemisphere as well as sphere. Now, to understand these concepts much more clearly, let us apply these concepts in solving few problems. Let us start with our first problem. A hemispherical bowl is made up of steel whose thickness is 5 centimeters. If the inner radius is 21 centimeters, find the total area of the bowl. Let us start with the solution. Let us assume first capital R and small r be the outer and inner radius of the bowl. Okay, children. And what is given? Inner radius I represented as r is equal to 21 centimeters and the thickness is 5 centimeters. Therefore, the outer radius will be the smaller radius, that is the inner radius, plus the thickness 5. But we have r is equal to 21, right, children? So, we write 21 plus 5. So, what do we get? Yes, the outer radius is 26 centimeters. Now, what is the total surface area of this bowl, children? Yes, it is CSA of the outer surface, that is outer hemisphere, because it is made up of two hemispheres, children, if you notice. So, this is the outer and inner one also there will be an hemisphere, right, if you see a bowl. Okay. So, outer hemisphere plus the inner hemisphere CSA plus this width, this thickness area, this is nothing but the area of the ring. Now, let us substitute the formula of all this, that is 2 pi r capital R square. Here I am writing because we are using outer area, right. So, that is why it is capital R square plus 2 pi small r square, because we are using for inner one, plus area of ring. Now, area of ring formula is pi into capital R square minus small r square. Now, let us take pi as common factor. If I take pi as common, we are left with 2 r square plus 2 small r square plus capital R square minus as it is and small r square. So, what do you get, children? 2 r square plus capital R square. Yes, you should get 3 r square. So, pi into 3 r square and 2 r square minus small r square. So, get only plus r square. So, now we will substitute the values of both capital R square and small r square. So, on substituting these values and simplifying, you get the value as 22 by 7 into 2469. So, on simplifying further, you get 7759.71. Hence, I can say that the TSA of the bowl is 7759.71 square centimeters. Let us start our next problem. The diameter of a copper ball is 4.2 centimeters. The density of the copper used is 8.96 grams per centimeter cube. What is the weight of the ball? Let us start with the solution. So, diameter of copper ball 4.2 centimeters. Then what is the radius, children? Yes, half of it. So, r is equal to 2.1 centimeters. Now, density of copper is given as 8.96 grams per centimeter cube. So, volume of sphere is given by 4 by 3 pi r cube cubic units. Now, let us substitute the value of r, children, here. So, we get 4 by 3 into 22 by 7 into r is 2.1. So, we get 2.1 whole cube. Let us simplify further. Now, 7 goes one time in 7 and in 2.1 it goes 0.3 times. Again 3 goes in 3 one time, and in 2.1 it goes 0.7 times. Now, what is left, children? Yes, 4 into 22 into 0.3 into 0.7 into 2.1. On multiplying this, you get 38.808. This is the volume of the copper ball. But what actually we have to find, children? Yes, weight of the ball. Density is equal to mass by volume. Now, from this, what is the weight of the ball, children? Yes, it is simply density into volume of the ball. Now, substitute the values of density as 8.96 and volume as 38.808. Let us multiply them. So, on multiplying, you get 347.72. Now, this is nothing but the weight of the ball. Therefore, I can say that the weight of the ball is 347.72 grams. I hope you have understood the problem clearly, children. Let us move on to our next problem. A tent is in the form of a cylinder surmounted by a cone having its diameter of the base equal to 24 meters. The height of cylinder is 11 meters and the vertex of the cone is 5 meters above the cylinder. Find the cost of making the tent if the rate of canvas is 25 rupees per meter square. Let us start with the solution. So, here you can notice a cone over a cylinder, right, children? And what is given? The diameter of the cylinder as 24 meters, which means the radius is how much? Yes, half of it. So, r is equal to 12 meters. Then the height of the cylindrical part is 11 meters, that is h1 I am assuming it as, so h1 is 11 meters. And the height of the conical part is 5 meters. So, I will assume it as h2 equal to 5 meters. Now, what is the value of slanted, children? Yes, we need to calculate using the relation L is equal to root of r square plus h square. Now, let us find the value of L, children. So, L is equal to root of r is 5. So, we get 5 square, h is equal to 5 and r is equal to 12. So, on substituting this, you get 169 under root. So, what is root of 169, children? Yes, 13. Therefore, the value of L is 13 meters. Then, we are going to find the area of canvas required, that is given by the curved surface area of cylinder plus the curved surface area of cone. Now, let us substitute the formula now. So, CAC of cylinder formula is 2 pi r h, but here height of the cylinder we assume it as h1. So, 2 pi r h1 plus what is CAC of cone, children? Pi r l. So, we are substituting pi r l. Now, is there anything common in these two? Yes, we have common as pi r. Now, take out pi r as common, you are left with 2 h1 plus l. Now, we will substitute the values of h1 and l. So, pi is 22 by 7 into r, radius is 12 into 2 into h1, h1 is 11 plus l is 13. On simplifying, you get 22 by 7 into 12 into 35. Now, again on further simplification, you get 22 into 12 into 5, because 7 goes one time in this and again here it goes 5 times. Okay, children. On multiplying, we get 1320 meter square. So, this is the area of canvas required. We are supposed to find the cost of making the tent. The rate of canvas is 25 rupees per meter square. So, the cost of making tent is the rate per unit into area of canvas. Let us substitute them. 25 into area is 1320. On multiplying them, we get 33,000. Therefore, the cost of making the tent is 33,000 rupees. So, children, till now we have learnt about surface areas and volumes of cone as well as sphere, and we have solved some problems also. So, before we conclude, let us recap what we have learnt in this session. If the line segment joining the vertex of the cone and the center of the circular base is perpendicular to the radius of the base, then it is called a right circular cone. The perpendicular distance between the center of the base and vertex is the height of the cone. The slant height of a cone is given by L is equal to root of r square plus h square. Curved surface area of a cone is given by pi r l square units. Total surface area of a cone is given by pi r into L plus r square units. Volume of a cone is given by V is equal to 1 by 3 pi r square h cubic units. A sphere is a 3-dimensional figure which is made up of all points in space which is at a constant distance from a fixed point. Surface area of a sphere is given by 4 pi r square square units. Surface area of a hemisphere is given by 2 pi r square square units. Total surface area of a hemisphere is given by 3 pi r square square units. Volume of a sphere is given by V is equal to 4 by 3 pi r cube cubic units, whereas volume of hemisphere is given by 2 by 3 pi r cube cubic units. So, children, based on the concepts that we have learnt, I am going to give you few problems to work it at your home and send it to your subject teacher. Okay, children, let us see those problems. A hemispherical bowl has radius 6 centimeters. The liquid is poured into cylindrical bottles of diameter 6 centimeters and height 4 centimeters. If a full bowl of liquid is filled in the bottles, find how many bottles are required. CSA of a cone is 2310 centimeters square and its slant height is 35 centimeters. Find its radius and TSA. The tent is cylindrical to a height of 7 meters and conical about it. The radius of the base is 4.2 meters and total height of the tent is 10.5 meters. Find the canvas required for the tent. The length of equator of the globe is 66 centimeters. Find its surface area. So, children, with this we have come to the end of our session. I hope you have learnt all the concepts clearly and also you have learnt solving the problems also. We will meet in our next digital class. Until then, goodbye and take care.